In this video, I'm going to quickly debrief the lab we did last week on heating water from ice water all the way up to boiling. Now, the point of this lab was to see how temperature changed as we heated the water. Now, your data in your lab should look something like this table on the left side. This is on the last page of your lab. This is the data you collected. On the right, we have the graph that we're actually going to graph our data on. So according to your data, the left column, the time, goes on the x-axis, and the right column, the temperature, goes on the y-axis. Now, the way this works to plot your data, we'll start with the x value, say at time 0, and then we'll use the y data, temperature 0, to plot a point at 0 on the x and 0 on the y, right at that 0, 0. The next data point will be at 0.5 minutes and a temperature of 0. So we'll go to 0.5 on the x-axis. It's right between 0 and 1. And we'll stay at 0 on the y-axis. So our second point will be there. I'm going to do 2 more points just to show you kind of the process. Next point, we have 1 minute and temperature of 2. So we'll go to 1 minute on the x-axis, and I'll estimate 2 as right about here. One more point, we have 1.5 minutes and a temperature again of 2. So I'll go to 1.5 on the x-axis between 1 and 2, and I'll go up to 2 on the y-axis. Now, if I kept plotting these points from my data on the left, I'll start to see a pattern emerge eventually. And once you plot all the points, you should see something like this appear. Once you plot all the points, if you draw a line, say, through them, you should see this general trend. Now, there's something odd about this graph. I want to separate this into 3 sections. One section right here, one section in the middle, and one section at the end. Your data should look something like this. What do you notice about this separation? What do you notice about the first, second, and third regions? So the reason why we see this is in the first region, this is when we had ice water. We essentially had a solid ice that was changing into a liquid. So this first region, we were talking about a change. What you should have noticed is that the temperature did not go up in this region. In this first region, when we had ice water, you didn't really see much of a temperature rise. The second region is when we just had water, when we just had a liquid. In this region, when we added heat, the temperature went up at a pretty steady pace. The end region is when we had boiling water. This is when water was turning into a gas, when water was turning into water vapor. So when the water turned into a gas, again, we did not see a temperature rise. Notice this region is flat as well. So what can we conclude about this? When we're changing phases in this first region and this last region, heat does not increase temperature. So during a phase change, heat does not increase temperature. If you have a single phase, such as the water, heat does increase temperature. And that's really the conclusion of this lab. Now, why is this? Basically, the heat during a phase change, what it does is it breaks up the structure of the atoms. So in this first phase on the left, or this first region on the left, you're breaking up the phase of ice into liquid. At this last phase, you're breaking up the water into gas, but it doesn't increase temperature. The only time you see a temperature increase is if the heat is just making a phase move faster, such as in this middle region. In this middle region, when you add heat, those water molecules are just moving faster. And that is the conclusion of our lab from last week.